Okay, guys, what I want to do now, I want to dive into some questions on my math lab, my stat lab, that'll look a lot like what your assignment number 9, the types of questions you'll encounter. I think with all the videos that I've put up so far, you have a pretty good foundation, but sometimes applying those in a different setting is problematic. So I am going to work some of these problems. All right, so the first one says if you use 0.10 level of significance in a two-tailed test, what will you decide if your z-stat is negative 1.16? Well, we should know that to 3 places, and maybe we don't know this. So let me go back to the main menu. Let me get StatCrunch up. And all right, let me. It's interesting. Okay, so 0.05. Well, it actually changed on us, didn't it? For the 0.05 level and a two-tail, what we decide if z is 1.74. We would reject, since it's a two-tail, we would have whether z is less than a negative number or z is positive. Our test statistic is higher than a positive number, again, because of the two-tail. These conditions right here just allow for a one-tail test, and this last one is just something goofy. So we know that if we're using a z that for a 0.05 level of significance, you should know by now that that's 1.96, but just in case it hasn't clicked in yet, we know that mean zero, standard deviation 1, that if we want that lower area to be half of our alpha value, that we have negative 1.960. So negative 1.960 and above 1.960. So check answer. State your conclusion. Well, since our test statistic is 1.74, which is not above 1.96, it falls in the non-reject region, so we are not going to reject H sub O. Okay, what is the p-value if in a two-tail hypothesis test that our z-stat is negative 1.72? Well, we've got to go to our calculator. So we want, since it's negative, we're going to go less than negative 1 point, guys, I forgot what it was. I need to write this down. 1.72. And that's going to give us the area here. But remember, in a two-tailed test, we also have to have that area as well. So I need to take 0.0427. So that looks like to me it's going to be 0.0854. Now, one-tail test, we wouldn't have multiplied by 2. So a quality control manager, I guess I don't know about you, but that's kind of hard for me to see. The quality control manager at a compact fluorescent light bulb factory needs to determine whether the mean of a large shipment of CFLs is equal to 7,507 hours. Population standard deviation is 1080. Sample size is 81, and our sample mean is 7207. So guys, we're going to use a Z test because our population standard deviation is known. So we want 7507. Did that put a 7 in there? No, it didn't. And 7507. 0.07. All right, what is the test statistic? Well, I'm going to go, I'm going to write this stuff down because I'll never remember it when I get over there. So our H sub O is mu equals 7507. Our population standard deviation is 1080. Our sample mean is 7207, so that's X bar. And our sample size is 81. So I need the test statistics. So guys, I'm going to go to stat, Z-stat one sample with summary. So the sample mean was 7207. The standard deviation was 1080. Sample size was 81. And we want to test 7507. All right, compute. So our test statistic is negative 2.5. So we want to go to two places. So it's going to be negative 2.50. What are the critical values? So use comma to separate the answers as needed. Well, we're at what significance level? 0.05. So that's going to be negative 1.96 and positive 1.96. What's the final conclusion? Well, our negative 2.5 is outside the range, so we're going to reject. So we can say that the mean life is different than 7507. What's the p-value? Well, the p-value is 0.0124. Looks like it wants us to go to 3 places instead of 4. Interpret the meaning of the p-value. Well, since it's less than 0.05, we're going to reject, so we have tunnel vision on A and D. There is sufficient evidence to prove that the mean is different. There is not sufficient evidence. So guys, when we reject, there is sufficient evidence to prove that the mean is different. So the interpretation corresponds with the alternative hypothesis. Construct a 95% confidence interval. So gang, going to have to go back in. Put in the information. It's the reason I wrote it down. And so the confidence interval, let's see what we got around to. We got around to 1 decimal. So it looks like it's 6971.8 to 7442.2. At this stage, you're just hoping that you don't commit a typo because you know you got it right. All right, compare the results. The results of A and C are the same because there is sufficient evidence to prove that the mean is different than 7507 because 7507 is not in our interval. All right, number 4, if in a sample of n equals 16 from a normal population, X bar is 55. Guys, I'm writing all this stuff down. And the sample standard deviation is equal to 8, so that tells me we're using the t-distribution. What's your statistical decision if the significance level is 0.05 and the null hypothesis, so the critical values? 4 places, separate by comma. All right, guys, so we're going to need to go to So we want our significance to be 0.05, and I need a t-distribution. So I want the area to the left to be 0.025, and my sample size is 16, so my degrees of freedom, and so what do we say, 4 places, so negative 2.1314 and positive 2.1314. Well, shoot. Hitting the wrong button here, gang. I don't know what's up. Determine the test statistics. So guys, this is going to require me to put everything in the hypothesis test. So my sample mean is 55. Sample standard deviation is 8. Sample size is 16. And it's wanting me to test mu 50 versus mu not equal to 50. So the test statistic is 2.5 to 4 places. That's interesting. State your statistical decision. Well, 2.5 is outside the critical values, so the test rejects the null, so it's either going to be A or C. The data provides evidence it differs from 50, so the answer would be C here. All right, manufacturer of chocolate candies uses machines to package candies as they move along a filling line. Although the packages are labeled 8 ounces, the company wants the packages to contain a mean of 8.17, so that virtually none of the packages contain less than 8. A sample of 50 packages is selected periodically and is stopped if the mean amount is different than 8.17. So we're going to have equal to 8.17, and we'll have not equal to 8.17. Now guys, I'm not above making a mistake on purpose, just to see if you guys are catching it. This isn't it, but who knows. Identify the critical values. Well, since the population standard deviation isn't given, I don't think. Let's see what kind of standard deviation we're given. So we're using a t-distribution. So we have degrees of freedom 49. And our alpha level is you might see the alpha level. Okay, okay, it's down here in this question. What's kind of goofy place to put it? All right, so we need 4 places. So degrees of freedom 49. And I want my lower tail to be 0.025. So I have negative 2.010. Okay, scratch that. It's at 4 places. So 2. So 4 places would be 2.0096. And 2.0096. All right, these are tedious, aren't they? Test statistic. All right. Didn't we just run a one sample T? Is this a different problem? No, it is. All right, scratch that. All right, so let's write down. So we're 8.17. It's the hypothesized value. N is 50. Sample mean is 8.164. And the sample standard deviation is 0.059. Guys, if I don't write that down, there would be no way in the world I would remember all that over here. All right, sample mean 8.164. Sample standard deviation 0.059. Sample size is 50. 8.17. And go for it. So we are looking for what the test statistic. So how many places? 4. So negative 7.7191. All right, so our test statistic is inside the critical values, so we do not reject. There is insufficient evidence to indicate a difference. Determine the p-value. Well, the p-value is 0.0 or 0.4755. Interpret the p-value. The p-value is the probability of attaining a sample that is equal to or more extreme than 0.06 away from. This probability of attaining a sample is equal to or more extreme than 0.06 ounces above. So guys, we know that it's if the null is true. It's a tedious little exercise. I kind of feel bad for you guys having to do this. Not too bad, though, that I'm going to change it. During a period of 1 month, a random sample of 27 approved life insurance policies is selected. The total processing time. In the past, the mean processing was 54, and level 1 has changed from... so guys, we should know that that is 54. And this is not equal to 54. All right, the test statistic. Well, guys, we got our data here, so I'm going to open it up in StatCrunch. And so we want the test statistic, 54 not equal to 54. Got our data now. It's not what we want. So our test statistic is negative, let's see how far we got to go to, 4 places, so negative 1.9639. Find the p-value. P-value is 0.0603. State the conclusion since our p-value is higher than our alpha. No, it's not. Hold on. Let's see. Does it say anywhere where the alpha is? Am I just... Okay, so the level of significance is 0.10, so our p-value is less than, so we're going to reject. And so there is sufficient evidence to conclude there's a difference. Now that's kind of interesting because if p-value had been 0.05, we would have failed to reject. What assumption about the population distribution is needed to conduct the t-test? Well, we want to be approximately normal. I don't know why that happened. Construct a normal probability plot to evaluate the assumption. So which one does it look like? So again, what I'm going to do is just like I showed you in the video, I'm going to graph and go to QQ-plot and plot that for variable 1. And the condition I see is it kind of comes down and then up, so that's the one that I'm looking for to match. And it looks like to me that's probably going to be the first one that does that. Doesn't match perfectly, but it seems to be pretty close. Closer than the other two. Do you think the assumption needed in order to conduct a t-test is valid? Gosh, I don't know. It's doesn't look too good. It's not really. It's not very straight. These things have a lot of wiggle room, but that's too much wiggle. So no, it's not. So it doesn't look like the normality assumption has been met. Accompanying data represent the amount of soft drink filled in a sample of 50 consecutive 2-liter bottles. The results are listed horizontally in the order of being filled, complete parts A through E. So alpha is 0.10, a drink different than 2.0. So critical values. Let's see. We have a soft drink is different. So we're using a T distribution, 0.10. So I can use either one of these. So I need the T. Sample size, I forgot to look at. 50, so degrees of freedom 49. And we're needing 0.05 since the alpha level is 0.10. We want half in the lower tail, so negative 1.6766. And positive 1.6766. The test statistic, well, I'm going to use the, it says that the data was in the table, so let's get it. Let's take it into StatCrunch. So I want to run one sample with data, variable 1. We are to test what, 2 and 2? Is this the same problem? Yeah. So 4 places. Well, okay. So 0.1548. Man, you guys better allow a lot of time to do your homework assignment because this is really tedious. So our test statistic falls inside the critical areas, so we're not going to reject. So there's insufficient evidence. Determine the p-value. P-value 0.8776. It's huge. Why not? Did I go to the right one? 0.8776. Oh. It's awful sensitive too. Interpret the meaning of the p-value. The p-value is the probability of attaining a simple mean is x below. If it's got to be true. So, guys, if the null hypothesis is true, is always the critical component of the correct interpretation. Wants us to run another normal probability plot. Guys, I'm wishing I hadn't done this many problems. I'm trying to get done before my daughters get home because I know they'll get loud. So that looks pretty good. That's very much right along the diagonal line. So yeah, I'm very comfortable with normality. So it looks like, to me, I'm thinking it's probably this one. So is the assumption yes, because the normality. Approximately normal. Wow. Examine the values of 50 in sequential order as given in the problem. Do there appear to be a pattern in the results? Well, let's look at the numbers. Looks like they're decreasing. So the amount is decreasing over time, so the values are not independent. Therefore, a t-test is invalid. So guys, it looks like that there's something else going on because independence means that the next measurement is independent of the previous measurement, but with a clear pattern, you have an independence assumption issue. All right, a one-tail hypothesis test, reject H bow upper tail, critical value, 33 degrees of freedom level. What's the critical value? So we have degrees of freedom 33. And we need 0.05 in the upper region. So 1.6924. All right, given our test statistic is 2.24, you're testing pi equal 0.8 against the two-tail alternative. What is your statistical decision? So our level of significance, so we know that negative 1.96 and 1.96 are our critical values. So our test statistic is outside, so we're going to reject because there is sufficient evidence to say the proportion is different. Well, finally, guys, question number 10. Cool. How do professionals stay on top of their careers? Of 1,000 surveyed members, 610 out of 1,000. Report level different from 0.56. So, guys, this is a proportion problem. That's kind of cool, all this drop-down stuff. All right. Our test statistic. All righty. So what? We're 610 out of 1,000. And P was 0.56. Kind of like it. Once you put in 0.56, it goes ahead and fills in the alternative for you because those have to be the same. So we're looking for the test statistic, right? So 3.1853. So 3.19, it shifted on us and only asked us for 2. That's annoying. The p-value is 0.0014. You know, this time wants us to go to 3 places. That's funny. All right, I'm just annoyed by this. State the conclusion. Well, guys, our p-value is definitely less than our 0.05 level of significance, so we're going to reject the null. So there is sufficient evidence to support that the percentage is different than 56. Well, gang, I guess we're done, which is great because my wife and my children just pulled in, so good deal. I'm glad this is over. I don't know about you. Take care.